In this episode, Sasha and Keoni further explore the parabola that has its vertex at the point 7, 0 and a distance of 3 units from its vertex to its focus. They derive an equation for the parabola using the Pythagorean Theorem and the definition of a parabola.
Here is your new parabola with the vertex at 7, 0. I'd like you to derive an algebraic equation to represent this parabola.
We got this. You already figured out the focus. You want to put that in the directrix? And P is still 3, right? We're always going to have. Okay.
P still 3.
Okay, so right there.
Oh, good line. Alright, and then are we going to choose a random spot to go from?
We should
Yeah?
kinda. Or
I don't know. Yeah? That's what we did last time. Can we do what we did last time?
sure.
Yeah. Okay.
Is the
Not on-
special point or
Not the special
okay,
point,
not
right?
the
Doesn't that make it
special
harder?
point. Yeah.
Okay, so like right there? Should I make it a different
Yes.
color? Alright, that's okay.
Yeah.
You want to do the lines? So we're going to try to figure out that point using the Pythagorean Theorem again, right?
Yes.
Okay. But it's weird now.
I know.
I don't get it.
Can you summarize what you've got so far?
So we found our focus in the last graph, and we figured out it was 7, 3, and then since
Go ahead,
our
write that in.
7, 3, just write F over it, or is that fine?
Whatever would be
you want
helpful for
F?
you.
Great effort here.
So F means focus?
Yeah.
Yes.
Great.
And this line right here will be our D, our directrix, and then our P is 3 because it's 3 under the x-axis. Yay.
Mhm.
And then Keoni, you drew some lines. Tell me about those.
I did draw some lines. I drew a line right here and right here.
What do you know about those two?
That our focus and our directrix are equal distance from our point.
Okay.
And then I just drew a line straight across to help myself make a triangle.
I noticed you drew that short little piece. What did
Yeah.
that help you do?
Finish off the triangle.
Yeah, so now you have a right triangle that you
Yeah.
can use the Pythagorean Theorem with.
Yeah.
Okay.
Mhm.
Could you also label that big red point over on the right?
Mhm.
So this is your general point on the parabola.
Yeah.
Okay, great. Let's see if you can figure out what the distances will be.
Are we going to do like y plus 3 again?
Yeah, 1 plus 3.
And then x up here?
Yeah.
But for like the whole thing, right?
Can you point to where the distance x is?
It's this entire line.
Ah, but your Pythagorean Theorem is only that short one.
I
X
know.
minus 7?
Yeah, do it.
Okay, I heard x minus 7
Yeah.
as a question. So,
No.
Keoni, what do you think? I mean, Sasha, what do you think?
Yeah, because that's what we did with our y's when we had to, with our p's, it would shorten it or lengthen our y's, but then for this one, it goes, since our vertex is in more, we would subtract this distance from it.
Great. Let's point out each one of those things. So in the distance x minus 7, can you just show me with your...
Yeah, okay. So the distance from here to
There is
here
what?
is x.
That's x. Okay.
Oops.
And then-
the distance from here to here is 7.
Ah, so you took that off.
Yeah.
So it's x minus the 7.
Yes.
And you get that other piece remaining.
Yeah.
Okay, great.
And should we do the y minus theory here?
It kind of doesn't fit with our focus. Huh?
When Sasha and Keoni first started working the problem, they had some trouble identifying a right triangle. Sasha said, "It looks weird." That may be because this is the first time they have worked with a parabola whose focus and vertex are not on the y-axis. But Keoni resolved their challenge by drawing a vertical segment to the focus. This created a right triangle. Sasha and Keoni used their method from Lesson 5 to identify the length of the hypotenuse as y plus 3, and the length of the vertical side as y minus 3. To find the length of the horizontal side of the right triangle, Sasha and Keoni first identified the entire distance from the general point, x, y, to the y-axis as x units. Then, they subtracted the distance from the y-axis to the left side of their triangle, which is 7 units. This leaves the distance x minus 7. Now that Sasha and Keoni have found the lengths of the sides of the right triangle, they compare these lengths with those for a right triangle on the base parabola.
Now, before you do the algebra, I'm going to pull up the one you did for the base parabola, and I want you to just look at how it's alike and how it's different.
Okay.
And the reason I'm doing that is because I think, Keoni, you said, how's this different than the one we just did?
Yeah.
I just want you to look at it.
Okay. I'll look
What's
at
the
that.
same and what's different?
Okay. Our focus is now over 7 spaces to the right, or 7 units to the right. And
our y stayed the same.
Mm.
So our y plus 3 are and our y minus 3 are in both of the graphs
And why are those the same?
because that distance didn't change. Our vertex only moved over right 7 spaces. It didn't go up or down.
Okay.
it didn't.
And your directrix stayed the same.
Yeah.
Okay.
And the biggest thing that changed for was the x minus
Minus
7.
7.
Now it's not just x. And there's an extra bit of x.
Yeah.
Great.
Sasha said that the biggest thing that changed when the base parabola was translated to the right 7 units is that the length of the horizontal side of the right triangle changed from being x units to x minus 7 units. But the focus and the vertex did not move up or down, and the directrix stayed the same. So the hypotenuse of the right triangle in both parabolas is y plus 3 units long, and the vertical side of the right triangle in both parabolas is y minus 3 units long. Next, Sasha and Keoni apply the Pythagorean Theorem to find the equation for the translated parabola.
Are you ready to do the algebra?
We're so
Yeah.
ready.
So y minus 3 squared plus x minus 7 squared equals y plus 3 squared. So we have y squared minus 6y plus 9 plus x squared minus 14x plus 49 equals y squared plus 6y plus 9.
You've been practicing, huh?
Yep.
All right, so now our y squareds are going to cancel out. And then you're going to plus 6y over here, plus 6y. And you're going to subtract 9 minus 9. They're going to cancel. So you're going to have x squared minus 14x plus 49 equals 12y. And oh my gosh. Oh my gosh.
What's the oh my gosh?
Since there's that extra, we're not used to having all that extra numbers.
Now, I'm going to recommend something. Notice how when you multiplied the x minus 7 term, I think
That
you
one.
only did that.
Yeah.
Notice how we haven't done anything with that.
Should we just keep it x
I'd
minus 7
keep it.
squared? Okay.
Oh, okay.
And the reason, you'll see in a minute. So if you rewrite it as the x minus 7 quantity squared. Now, can you get that as y equals something?
Y
That does
equals
look better.
x minus 7 squared over 12.
When Sasha and Keoni got to this point in the algebra, they were puzzled. As Sasha put it, they are not used to having all those extra numbers. The expression x squared minus 14x plus 49 came from multiplying x minus 7 by itself. The teacher suggested that they leave it as the quantity x minus 7 squared. In the next episode, Sasha and Keoni will see y, but for now, they went ahead and solved for y by dividing both sides of the equation by 12. The equation for the parabola is y equals the quantity x minus 7 squared, all divided by 12.